Okay, good afternoon, folks. This is the first lecture of week 12, the last week of the course. Friday is going to be the last time I'm going to be meeting with you guys at 8:30 in the morning for lab 51 and 1:30 in the afternoon for lab 52. We are no longer giving lectures, at the end of this week, of course, and the first 3 days of next week, Monday, Tuesday, and Wednesday, those are set aside by the registrar's office for classes or sections that have lost hours because of the Victoria holiday and the civic holiday yesterday, and also for July 1st. Now, all of these have been recorded and posted. The expectation was that when you return from your statutory holiday, you have several days to watch those lectures. So you are responsible for all of them. As far as I'm concerned, Friday is my last encounter with you until the final exam. And you already know that the final exam is in the take-home format, and the details were mailed to you, emailed to you individually. And please read it carefully. There are 10 points that you have to pay attention to. Okay. Before I do the last item of this course today, because on Thursday when I meet with you, and on Friday in the labs, I'm going to go through the sample test that I'll be mailing out. Are there any questions before we move on? Okay, no questions. Very good. And let me remind you what we did last Friday. We took an assembly made of 2 parts. I used only 2 parts, and I parameterized it, and I showed you how to do it. Now today, I'm going to show you how to make a design table and use it in an assembly, okay? Or let me put it this way, it's not how to use, it's just that when a design table given to you for an assembly, basically how you work it out. I will do 3 examples. The first one is very simple. I mean, in fact, they're all simple. So we have a block here. Think about it as a box. And then there's a cylinder. And the cylinder is supposed to fit there. They must have the same height and obviously the same radius. And the design table that we want to make is really just involving the radius of this and the height of that. Now, obviously, you can put the, for example, dimensions of the box, but that is not what I've decided to do. Okay. So the idea is that you go, once you create the design table, you go and select a specific row, the whole thing, and update the assembly. The whole thing should resize and they should fit together exactly like what you see. And remember, I want you to put the assembly constraints here. In other words, if you move these things apart and you update, they should go back to where they belong. This is a very simple thing. Now, when I did design table for parts for you last Tuesday, I pointed out that the problem with design table is that there are different ways of doing it. Okay, that example that I gave you, somebody knocks on your door and wants to go to the second floor to an office room. Well, the different ways you can take the person there. One is through the front door, the stairs, and then the other one through the ladder in the back. And it's the same issue with design table for assembly. Okay, so I'm showing you only one way of doing it. Okay, there are other ways. Now, so the first thing we're going to do is to create a product. And immediately I'm going to save this thing, file, save management, save as. Okay, so let me move up here, and yeah, I'll make here a a folder for you guys, new folder. So I'll call it section 1, and this is example 1. Example 1. Okay. So whatever we do is going to go there. Now I'm going to insert a first part, insert a new part in there. And I'm going to call it the box. Right click properties, box on box, box and box. And we're going to make it. So let's go to the part design. On that plane, I will sketch. I'll make a centered circle, centered rectangle with a circle in the middle of it. And because we're going to control the radius of the circle. Now, by the way, I have no idea what the size of this edge is. So let me see for a second. So this must be around here. This must be around I don't know, 6. That's fine. Okay, so because we're going to control the radius here, I dimension it. And the reason I check the size of this is that notice that later on my radius is going to be 1 or 1.5. I just wanted to make sure that the sketch was not going to be self-intersecting. That's all. So we exit and we pad it. There we are. Okay, now let's go ahead and insert the second one, which is just a cylinder. So insert, new part, say no, and right click properties. This is a cylinder. Cylinder and cylinder. And all it is a circle, and which is padded. So we go to that part on right here on that plane. I'm going to sketch a circle. I'm not going to worry about the assembly constraints at this point. So later on, we're going to do that. You don't want to lose marks on that in the event that you have parameterization or design table for assembly. So exit. And you pad it? Yeah, so let me make it a little bit taller. Good. Obviously, we want these two to have the same height later on. And let me, by the way, change the color of this. Yellow. Okay, good. Let's go all the way to the top and save. Save the entire assembly, which is going to save the parts with it. Then I'm going to create my Excel spreadsheet. Now you could have done it earlier, it doesn't matter, but I didn't. So let me go ahead and make my spreadsheet. Okay. So there was R, and I said always put units. Don't make it complicated for yourself. Over H, R in inches, H in inches. Let me see for a second, what were these dimensions? 1.5. Okay. So this is 1.5. And believe me, I already forgot. What is that? 0.4 and 2. 0.4 and 2. And that was 1.5 and 0.3. 1.5 and 0.3. Okay. Remember, you have to save this thing, and the Excel spreadsheet is something that you have to upload with your homework or with your test if there's a question that requires Excel. So File, Save As, Browse in that folder. I'm going to put in the same folder that that I put your files in it. So where was that? Desktop, all the way down, right there. And you're section 1. I'm going to call it example 1. Something that you have to give us, otherwise you lose the marks for that entire problem. Okay, good. Now, we're going to go to right here. Now, let me remind you, when we did this thing, part design for this, what I did, what was the next step that I did? When I did it for parts last Tuesday, actually it was, I think, last Thursday, yeah. So what I did is I went to f of x and I renamed the dimensions, the weird dimensions, so that it matched the names that I have in the Excel spreadsheet. Okay? You didn't have to do that, but that's what I did. Here, I'm not going to do it like that because it's, if we go this route, the one that I'm teaching you or showing you, it's impossible. Okay, so I'm not going to rename those. Okay, and yeah. Okay, so what we're going to do is we're going to go to the planner right there. You see that? There's a planner or design table. That's what it says. It says, do you want to create this thing from a pre-existing file? The answer is yes. It says, okay, where is it? Well, this is why you have to give it to us. Otherwise, we can't mark your test. So we go to that folder where I see you're in section 1. So I put your Excel spreadsheet. It says, hey, if I see anything in the database that matches the name in your Excel spreadsheet, should I assume that they are the same? The answer is, of course, yes, but there's nothing in the database that I renamed to match R and H. I can say yes, but nothing is going to happen. You can see that right there. There's no table here. Because when you click on the association, it said, oh, you had an R and an H in your Excel spreadsheet, and I have no idea what to do with it. That's what it's saying. So here's what I'm going to do. Okay, I'm going to click on the product. So all the dimensions that are associated with the block is going to appear. So this thing, this is the radius of the hole in the block, and I'm going to associate it with this R. Okay? And this height here, the padded height, this guy, is associated with the H, associated with that. So it's selected. When I selected it from the screen, it went to a database, found out where it is, it highlighted it, and I want to associate with this. Okay. Ideally, now we never had this problem for the part, but ideally, these are also going to be associated with R and H. But look, it's all gobbled up. It got gobbled up. There's nothing there. I can't do that. These two disappear. So the way one way to handle that in the case of assemblies is this. Okay, first of all, don't say cancel this. Don't say cancel. First of all, look, configuration. Here are the two. Yeah. Say, okay, don't cancel it, because if you cancel it, the stuff that you did, design table is going to go away. Say, okay. Now, what we're going to do, we're going to say the height of this is equal to the height of that. The radius of this is equal to the radius of that. It has nothing to do with R and H. It has to do with equating this dimension equal to the dimension that we see on the screen here. So you go to f of x, you click on the product so that everything up here. We say this radius, see, it picked it up, add a formula equal to that dimension, that radius. And this height for the cylinder, add a formula equal to that height. We say okay, and we say okay. And now we're going to go to our design table. We have the design table. We have the two equations that I just made. We go to the design table. Okay. So let me move this. This is the first row. Apply. Okay. And update. See that? They have the same height. Remember this? This had a height of 2. Now they have the same height, and they have the same radius. You want to go to the second row, go to the design table, select the second one, apply, update. When you update, unfortunately, this closes. So I don't know. There we are. You see this? Go to the last row, apply, and update. There we are. And we're good. Anything that has to do with material, name, and things like that, you handle it the same way. Okay, so are there any questions? Okay, no questions. I will kill this. Yeah, second problem. This is the problem that I did for you. Let's see now. This was on Thursday, but I parameterized it. Now I want to use the design table to do this, and that's where we are. Okay. So we go to the. Let's see now. Where is it? We go to CATIA. We start a product file. All right, right away save it. File, save management, save as. Now, if I'm going to put this is example 1, section 1, example 1. So I'm going to make a new folder. Section 1, example 2. Section 1, example 2. Okay. Everything's going to go there, including our Excel. Now I'm going to make the box and the wedge. First, insert. Let's do the box first. Insert a new part. Right click, properties. So this is going to be a box. Oh my God. Remember, I forgot to put assembly constraints. I got excited that it's working, and I put I didn't put the assembly constraints there. That means I'm going to lose marks. Do you remember that? We make sure we don't do it here. Okay. Happens to all of us, right? Okay. Let's go make it. On this plane, I will sketch. Now, because I want to make nice and symmetric here, so I will use this for the, later on to do the symmetry thingy. So, and I really boo-booed this when I did it for the 8:30 lab this morning. And I'll tell you why. I didn't mean it. It just happened. And I didn't realize what the issue was until I wasted a lot of time. That's why I couldn't do the third problem for them. And I'm going to put this one on YouTube instead of the one that I did with the 8:30 class. Okay, first of all, let's do the following. Let's make stuff symmetric. Left one, control, right one, control, middle axis, symmetric. Let's put this guy on that vertical axis. Yeah, coincident. And let's make this point, this point, control that point, control the middle axis, also make it symmetric. Okay, very good. And just to have a rough idea of what the sizes are, because remember, for the second one, for this problem, I'm not parameterizing the width of this. So I want to have an idea of what this width is so that I don't put some dumb numbers there that are not going to work. So for example, this says 7, right? So notice that 7, if you make that angle too big, then the line is going to go past that the left edge, and then it's going to screw it up. So that's what is good. Good. All right. So what else do we have to control here? We have to control this angle, and we have to control the distance from this point to that point, but the vertical distance. Right click, vertical distance. Okay. Or I could have done this point and that line, either way. And we want to control this height h. This is going to be eventually h. And exit. This is where I badly screwed up this morning. When I pad it, somehow I managed to put a number here too. I don't know how it happened, but no. And that really chewed up on time because I couldn't figure out, why is this not working? Okay. Anyway, right there. Now let's do the wedge. So insert, new part in there. No. Right click, properties, wedge and wedge. Wedge and wedge. Let's do it. So on that same vertical plane, I will sketch a triangle, because that's supposed to go in that cutout there. And you can see that this is not closed right now. So this control, the different ways of fixing this, that you make it coincident. Okay, good. Let's make it nice and symmetric. So left, control right, control this middle axis, make it symmetric. Okay. Now let's do some dimensions there. So dimension between this angle and that angle. Oh, sorry, this edge and that edge. And dimension between this point and that height. Try again. Between this point and that line. That's going to be matching this guy, which is my W, I believe. Okay, exit. Exit. Pad it. And I'm going to make it on purpose, make it longer so that you can see the difference when we fix it. Right click properties. Yeah, I use a different color here. I use, I don't know, maybe pinkish. Okay, good. Go up there. Save everything. Create your Excel spreadsheet. So, Excel spreadsheet. Specify the dimension, or dimension meaning units. So my table, I'm not going to look at it. You already saw it. So IN. This is WIN. This one is LIN. And this one is alpha in degrees. Good. Put those numbers in there. So this is 5, 8, 2, 1, 2, 1, 1, 2, 1. Oops. Okay. L is, that's the padding thickness, 2.1. Oops. 2.1 and 1. And the angle alpha is going to be 90, 45, 100. You're going to save this file, save as, in that folder, Example 2. I'm going to call this thing example 2. Okay. And then you have to close it. Okay. So we go to the design table right here. Pre-existing file. Sure. The correct Excel spreadsheet. Example 2. And then this guy is saying, should I associate anything that matches? The answer is yes, but there's nothing that's going to match it. Nothing. You can see that. Tables are created. But you go to association, CATIA tells you, hey, in your spreadsheet, I saw these things. I have no idea what to do with them. Well, we're going to associate it with the stuff that we want. We're going to associate it with the stuff down here, and then we create an equation between these dimensions and the one above there. Because you can associate it with this and that, the way we are doing it. Okay? So you select that guy, this guy, and this is going to be associated with H. You select this. Now this actually I don't use it. Okay, I dimensioned it because I wanted to know how big it was. Somehow it stayed there. Okay, W is right here. This one I just leave it the way it is. I'm not using it. Associated with W. This is associated with alpha, and that length. See this? This is associated with L. And now if you look at your table, it's over here. And if I just say, okay, the first row, an update, it's going to fix this thing according to the first row, but it's not going to do this one because there's no equations here yet. So we're going to go to f of x. We're going to click on the entire thing. And we're going to say, for example, this guy, add a formula equal to that guy, and that guy was W, right? And this angle, add, oops, yeah, no, not that one. Cancel. I don't want that. It's this angle. This angle, add a formula equal to that. See, the order that you pick these is going to make it work or not work. Be careful. Now it should be okay, I hope. So we have our design table here. We have the equations that we created. And let's go ahead to our design table and see whether it fixes it. First row, okay, and update. This better become the same size as the wedge up there. Oh, it did not. Okay, let me see. What did I choose for? I better go and check these things now because I don't know what I did. Let me delete this because this is the one. This is the one. The angle is okay, but this is not. So let me delete this. Okay, and go to assembly. Move these apart so that I can see things better. I'm jinxed on this problem. Okay, good. All right. Now, okay, so let's go ahead to f of x. Okay. Oh, before I do that, I want to make sure that the dimension that I created here for this is correct. Okay, so let's go to that wedge. Double click on it. I put a dimension here between this vertex and that, right? So that is fine. That is correct. That's correct. I don't see any issues here. So let's go exit and go to f of x and try it again. Okay, so f of x, you click on that. This dimension, this guy, must be equal to the dimension here. So I know what I did. I picked the wrong edge. Okay, so you click on the product. I picked this. That's a mistake. It should have been that guy right there. This guy, this dimension. I picked the edge on the side. Okay? All right. I bet now it's going to work. So go to the product. The first row is selected. Where's my equation? I forgot to do my equation. Okay, let's try. Oh, wait a minute. Good. I think I inadvertently closed that. So f of x. Okay, let's try one more time. Man. Okay. This guy, add the formula equal to that guy. Say okay. Say okay. Should be two equations here. All right. And now we go to our design table. This is the first row. So if I say update, that should become the same size as that. And it does. Okay. Let's go to the next row. Okay. Update. You see? Oh, whoa. This one got screwed up. We better check that. And we're going to find out. We're going to find out. This should be this. Oh, yeah. The pad I forgot to do. Remember? The pad of this should have been equal to that. I forgot to do that. Let's do it. Okay, third equation. So click on product. This fellow, add a formula equal to the pad of this guy, which is right here. Very tiny, right there. Okay. Okay. And when I update, they're going to become the same size. Or else I'll give up. No, I won't give up. Right there. So let's go to the next one. Last one. Apply. Okay. Update. There we are. You see that? They're the same size. And let me go to assembly design because I want to move them closer to each other so that you can see it. Translate in direction Z. Right there. Believe me, these are the same size. Now, you don't want to lose marks. So coincidence between this face and that face. Okay. Coincidence, and there are different ways of doing it. This edge and that edge. And coincidence between this edge and that edge. And update. You go back where it was. Now you get full mark for this. Let me show you what I have in mind. So actually, if you go to assembly design, move these things apart, do some crazy rotation like this. Where is it? Like, oh, that's not a crazy rotation. Rotation, like that. And like this. And go to design table and select, for example, the first configuration. And when you say OK and update, it'll snap back where it's supposed to go. Okay, so that takes care of this problem. And it's the kind of thing that you will experience. And although you make mistake, you go fix it. Last problem. Any questions here? Okay, now before I do the last problem, which we also did on Thursday, I want to remind you that when it comes to the sample test or the test, the final exam, read the stuff on the paper carefully. This is why we are giving you all this time. Okay, there is no excuse, saying that or don't tell me, but saying that, oh, I didn't see this, or I didn't see that, or I didn't know that. Everything that you need is on the paper, okay? And please pay attention to the stuff that's there. Okay, so this problem, we did it. The only thing is that I want to do it with a design table. Okay, so we're going to make two cones, the outside or the outer, inner, and we do that, not parameterize it, but use design table. So let's go ahead. And you remember, that if you have an assembly problem, you have to give us the part, the product, and all the parts that product is using. And if it's a design table, of course, you have to give us the spreadsheet also. All right, so let's start with not that, this, the product file. Let me just see for 1 second here. Okay. So save this thing right away. File, save management, save as, up, a new folder, section 1. Example 3. Example 3. Everything goes in that folder. Say OK. And now we go and create our parts. So insert, new part in there. Right, let's call it outer. Properties. Outer cone, presumably. And this is outer. Say OK. Let's go make it. Double click on outer, on a convenient plane, on that vertical plane. I'll use a sketch, a triangle. The outer one, the way I'm going to do it is like this. Because you want a cavity in there so that the inner one goes in it. Okay, so let's put some dimensions. Dimension from here to here is going to be h. That's the one of the things that we're going to control. Angle between this edge and the vertical axis. This angle is going to be alpha later on, and another dimension between the inner edge and this guy. This is going to be our beta. Here, beta later on. So exit and shaft it about the z-axis. That's good. Okay, that's this guy. And then we're going to insert the inner one. So insert a new part in there. Say no. I wonder how many of you have ever read that thing or paid attention to what it actually says. So properties, inner, and inner. Okay, we'll make it. Double click on this, on that same vertical plane that you did the other one. You don't have to, you can take anything else. You just it's convenient for me to do this. That's all. So coincident. Actually, you know what? No, I'm not going to do it here. I'm not going to do it like, I'm not going to make it easy for you. Delete this. Delete this. Well, let's exit that. Yeah, exit that. Okay. So sketch on the horizontal plane. I want to make it really hard. No, it's not hard. So there we are. Just to throw you off, that's all. Okay. The dimension from this top point to here is going to be eventually h. Let me try it again. From this point to this point to this edge, eventually it's going to become h, and this angle is going to become beta. This is supposed to fit inside of that cavity. This is going to become beta. Exit and shafted about the that'll be the y-axis, I think. Yeah, y-axis. Good. Okay, let me change the color on this one too. Right-click properties, graphics, like this color, turquoise. Very good. Okay. Now, let's go make, first of all, save this. Go make our design table, Excel spreadsheet. Go look at my other computer to see how the table looks like. So, little h in inches, alpha in degrees, beta in degrees. Okay, and I'm going to put these numbers in it. These numbers in it. So 5, 5, 5. Come on. 5, 8, and another 8. 90, 60, and this thing is 10. And obviously beta is smaller than alpha. It's going to be 45, 30, and 5. So save it. File, save as, browse that folder where I put all this stuff in it for problem 3. Okay, so that's going to be example 3. Okay, close it. You have to close it, otherwise you can use it in the design table. So click on the design table. It's a pre-existing file. Get that proper Excel spreadsheet. That's example 3. It's right there. It says, do you want me to associate automatically? Yes, but it's not going to happen. You can see that. It says, hey, I found these things in your Excel spreadsheet. I don't know what to do with it. We say, fine. So let's click on the product. So H is going to be this height. This height is going to be associated with H right there. See that? This height, which is picked in the database. There is a bigger angle. This is the bigger angle associated with alpha. There's a smaller angle associated with beta. Now, obviously, if you go to the configuration tab, it's there. By the way, the reason these become too long is that, remember, when I renamed it, this became very short, but I didn't rename things, so this is the exact name in the database, okay? So this is the first row. We say okay, and if you update, this cone is going to resize. Oh, something is wrong with that sketch. What happened here? Okay, so let's clean this up. First of all, let me undo these so that I go back me see for a second. I've got to go back to that sketch. Okay. So 45, what is this? 90 degrees. Oh my God. 90-degree angle? That's going to go to infinity all the way. That's what it is. So we go to our design table. This cannot be 90. Okay, so we go to edit table. This number, let me make it, I don't know, maybe 80? 80 is okay, you know, save. It's going to become very fat. Close it. I saved it and close it. First row. It reminds me that this has changed. This is fine. And update. Yes, right there. Because I made it 80. 90 goes to infinity. All right. So let's go to another row. This is terrible. Another one. Update. Okay, it's hiding there. Now that doesn't surprise you because we haven't done the equations yet. Okay, so let's go to the assembly design. All we did is we're changing this now. We have to create our equation so that the inner one also changes. Go up, 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 up. Okay, terrible. Okay, so you go to f of x. You click on the product, so all the dimensions show. Now this, what was that height? Okay, this is kind of hard from that. I think it's this one. I think this guy. Yeah. Yeah, this guy. Add a formula. Okay, actually, wrong. I have to get the one from this fellow equal to the other one. Okay, I want this guy. Add a formula. Go to, what is this guy? Let's fit everything here. I think it is, I think it's this. Yeah. And the angle beta from this fellow. Terrible. The angle beta from this guy, it must be this. Add a formula equal to, now we have to get the other one. I should have resized this so that it was easier to see. It should be this. Yeah, I think so. Okay. Okay. Okay, let's update it. Yes, this goes in there. Let's check it out. Assembly constraints, this axis and that axis, and coincidence between this and that. Update. And there we are. Okay. And let me actually change the rendering here so that you can see it better. Or either that or change the translucency on this outer one. Right click properties. Translucency, transparency. Okay, good. Okay, so let's go to our design table, check the other dimensions also, other rows, that's what I mean. So the first one was okay. That's the first one, really fat. Second one we tried already. Okay. There. Save. 149. Are there any questions? Okay, if there are no questions, folks, I will see you on Thursday. Now, Maybe in a few minutes, maybe in an hour or so, I will send a sample test, a sample final exam to everyone, because I'm going to meet my 4 o'clock class with the other section, and I want to discuss some of it with you. Might as well get a heads up too. So yeah, we're going to do that on Thursday with you.